my organization is a nonprofit research group, and we specifically work on firefighter health and safety, attack effectiveness, community resilience. Maybe I'll make it to another slide. I don't know. Oh, goodness. Okay. Yeah, I'm not quite sure if I'm not quite sure why this is jumping around a bit. So that's fine. We'll just, if you could go, yeah, we'll start here. That's okay. All right, I'm ceding control of the PowerPoint slides. So here we go. So a little bit about what Clean Cab for Firefighters is before we get started. So firefighters are exposed to obviously a myriad of toxins and carcinogens on the fire ground. The concept of Clean Cab is that their PPE, their gear, and their tools are contaminated while they're fighting fire, while they're doing their job. And as a result, when they get back into their apparatus, whether it's a fire engine, a fire truck, we also work with aviation and other support folks, the cab itself becomes contaminated with these carcinogens. Protocols for reducing that contamination can include things like on-scene decon, so cleaning the PPE, doing a gross decon before they get back into the cab, isolating the PPE, isolating respiratory devices like the SCBA, the self-contained breathing apparatus, from the cab of the truck. But this tends to work better for structural firefighters. Next slide, please. So when we think about Clean Cab for wildland firefighters, the reason that we're approaching this as a different problem is because the techniques for fighting fire in the wildland are different. For a structure defense or a response similar to that, the firefighters typically show up on scene. They're able to do their job, put out the fire, whatever it is they need to do. They have the opportunity to either gross decon and isolate gear and then get back into their cab, so a clean cab type practice, and immediately return to the fire station and do showering and some other immediate decon. If you are on a wildland fire, you're typically working much longer shifts. You're on site for longer, but specifically the firefighting techniques are different. So without getting too much into the terminology, because I'm not quite sure how it may vary between Canada and the US and other places, tactics like bump and run or similar techniques where the firefighters are in and out of the apparatus consistently while they're working on the fire can lead to significant contamination. So the purpose of this study was to understand the scope of the problem and potentially address how to reduce occupational exposure. Next slide. So, why do we care about Clean Cab in wildland and wildland urban interface fires? There's three primary routes of exposure. There's dermal, there's respiratory, and there's oral. These exposures, all three of these are happening to our wildland firefighters during incidents, but they're also receiving the secondary exposure of once the cab of their apparatus is contaminated, they're getting some secondary exposure predominantly from air quality and then also from dermal contamination. We'll talk about a little bit more about that in a minute. So we really wanted to understand the scope of the problem and propose common sense solutions. Next slide, please. So some of the assumptions, again, are that wildland firefighters have different firefighting tactics that are affecting how the contamination in the cab of the apparatus is happening, and as a result, how we can approach reducing that contamination. We really wanted to understand and identify the high areas of contamination and other novel factors included in occupational exposure risk. So the in-cabin air quality was a huge factor that we were interested in, not just the dermal contamination from the actual cab. So we also wanted to provide some general recommendations and solutions to reduce occupational exposure risk based on these results. Next slide, please. Thank you. So again, really wanted to understand contaminated areas within the wildland and WUI apparatus and identify novel factors, provide general recommendations. So next slide, please. The project we actually worked on began with the Austin, Texas Fire Department. So we had a pretty fun time hosing down a lot of the firefighters with glow germ, which is essentially just a trade name for a fluorescent powder, and let them go about their job. They ran through a wildfire training exercise where they simulated bump and run tactics and basically responding to a wildland urban interface fire in a neighborhood. After the fact, we went with UV lights and took photographs of the whole interior of the multiple apparatus. So we looked at a couple of different trucks and engines that were available. Next slide, please. So some of these might not be surprising, but first of all, I wanted to point out that this was a qualitative assessment. So while we looked at where the UV fluorescent powder was within the apparatus cab, it was qualitative. We basically ranked areas high, medium, and low contamination based on roughly the surface area that was covered. So high was about, I believe, 10 centimeters squared or larger. Medium was 5 to 10, and then low contamination areas were less than 5 centimeters squared, generally, surface area. And went through, and there was a bit of weighting done too, because not all apparatus had the same number of respiratory devices and other things. In general, not surprisingly, the floor of the apparatus is a huge source of contamination. The really interesting ones for us were the communications, the comms, so the headphones and the microphones that the firefighters use. And then also coolers where water bottles and drinks were stored were highly contaminated as well, which points to the concern for oil route of exposure as part of contamination of cabs as well. Yeah, next slide, please. So, the materials really matter. Again, not surprisingly, cloth was a huge issue. So cloth seat covers, cloth seats, huge sources of contamination. The particulates just really tend to cling to those materials. And then on the other end of it, hard plastic, metals had lower contamination. Next slide, please. So really importantly, that I wanted to cover was actually the interior air quality that was assessed as well. We took contaminated PPE, so PPE that had been exposed to smoke, and placed it in the interior of the cab and took some measurements. Next slide, please. So the measurements we took that are displayed on this graph here were specifically looking at VOCs, total VOCs, and total particulate matter. But we looked at other chemicals as well, including sulfur, oxides of nitrogen, and other chemicals. But the trends were very similar. So just for clarity, the VOCs are in blue, the total particulate matter are in orange. And because the graph might be a little bit hard to read, you can see the numbered section. The graph reads left to right. So at baseline, you can see the relatively low VOCs and total particulate matter, where the huge spikes when the PPE was introduced into the cab, followed by a big drop when the HVAC, the air conditioning in the apparatus, was turned on. And then again, when the PPE was removed. What was interesting was that after the PPE was removed and the AC was turned off, what you'll see is another increase in the VOCs and the particulate matter, which indicates that there is that secondary exposure. There's continuing contamination even after the source of that contamination was removed. Next slide, please. Okay, we're going to finish up. Let's see. So we repeated this also. So it says, say 48 hours post-exposure, but specifically we were looking at if you were to work a 24-hour shift, expose the vehicle, take the PPE out, and then get back in the vehicle after a 24-hour shift. The reason why we did this is because most of the wildland firefighters that we work with and that we know do not typically have the ability or I guess the desire to wash their PPE at the end of every single shift. They're getting back into the cab with contaminated PPE. So again, the spike when it's introduced, and then reductions when the AC was turned on and the windows were open. So I know I'm supposed to wrap it up. I just have one slide. It's a very important point, I think. Next slide. Okay. It's not on this slide, but the important thing to note is that even on an active incident, so when there is smoke present, about 40 to 50% of the time, the air quality in the cab of the apparatus was worse than the air quality outside the cab. And that was on an active incident. So we didn't get a chance to go through the recommendations, but all of our information is available on our website. And the good news is that my colleague, Dr. Matt Ron, is going to be speaking as well. So he can probably give some additional information.
All right, if you could thank the speaker. You can also show your recommendation slide as we go to questions.
Yeah. Let's see.
So we have a bit of time for one quick question. Anybody in the audience? All right.
Hello, I'm Dennis Turpin, retired University of Illinois, Chicago. So I'm really interested in this topic. And when you're looking at air quality 48 hours later or after the HVAC was turned on or off, do you know if the HVAC filters on the apparatus were HEPA filters?
He's nodding yes.
I
Yeah.
saw that. Yeah.
No, that's okay. Yeah. So they were HEPA filters.
Okay, because I worked the Lahaina fire, and that was a big difference with the air quality, because a lot of those construction vehicles did not have HEPA filters in their HVAC.
Yeah, it's definitely a concern. And just for context, we do a lot of work with air quality and smoke and all that. And we'll be spending a bit of time out in Lahaina in October on a community resilience project as well. So any other questions? These are just the general recommendations. So the easy ones are making sure you don't have cloth seat covers, making sure your AC and is maintained, filters are maintained regularly. And then any sort of wiping down of the interior cabin of the cab, that you can do is helpful.